Okay, welcome to my first recording of some coding here. There's probably too much to explain right off the bat. It'd be really boring, so I'm just gonna kind of try to jump in and do some coding. But I'm using this library I've called Fluently. It's just basically like a Fluent interface on top of some, I guess, primitives for doing some graphics stuff. It's not really graphics, but more just calculating points, um, because I'm more mathematically generating some images. It'll make a little more sense as I jump into it, I suppose. So, um, let's see here. We have. We'll just ignore this function for now up here. So when it runs, a little bit of contextual information. It's going to draw something 1,000 pixels wide and 500 pixels tall, and the path where it's going to throw it just in a temp folder on my C drive. This thing helps me save the files. So anyway, what I'm doing here at first though is, well, up in the using statements, it's kind of, the Fluent interface is like wrapping a function that goes from a unit fraction, which is basically just kind of a value from 0 to 1 is what's expected from there, and it's going to get a value for 0 from 0 to 1 from some two-dimensional point. And the simplest way to start out, I suppose, is you just create a black image by creating a function where, given a point, it returns 0, and 0 being no brightness. So anyway, I'll just run that, and it creates this image. So 1,000 pixels by 500 pixels, and it's just black. So if we go back in here and say you get the idea. White is going to be 1, but let's do a second one. And for this one, we'll take P and take the X value. So P just has like an XY value. And we'll save it. I'll just call it 2 because I'm not very creative. And we run that, and it runs, and now we have this image. So that does look like a white image, but if you look like really carefully on the left side there's like a 1 pixel line of black. Now what we have to do is, that's why this center scale thing comes into play. The way the Fluent library works is it uses a bunch of generics, because C#, with generics, it was a kind of a way to do the Fluent interface, have it be pretty flexible, but it's makes for kind of hard to read code, or long code sometimes when you're creating extension methods and stuff. So anyway, the function that's being fluently worked with is coming in here, and then we're going to scale it and translate it, and that's why it's called center scale. It's scaling and translating it so that we can kind of more see, like putting 0 at the center of the image. And the reason we use the context is because the context knows what the width and the height of the image is, and yeah, then it can figure that out. So let me show you the image it generated. So down the center would be 0, and if you notice back here in the code, we're kind of, well, I'm scaling it not to a full value, not where 1 is at the top and -1 is at the bottom. It's based on height. So 2 is at the top and -2 is at the bottom. And so you'll see that this over here would be 1x. I think that's right. Actually, maybe it is 1 up here and 1 down below. Anyway, I guess we'll see. We'll figure it out more when we dig into it a little bit further. But yeah, so there's our x gradient. And once it exceeds 1, it just caps off at 1, or once it goes below 0, it just goes to 0. So it kind of clips those values. But let's do something a little more interesting. Let's try to do px times py, and well, we'll still call that 2, whatever. And if we look at what we got now, that's kind of interesting. It's multiplying both the x and the y value, so we can kind of see the mathematical representation of what that is doing to the value of the image. Yeah. So let's go back to the code and let's see, what can we do that's kind of interesting to this. I got an idea. We'll take the x and the y and do a modulus of 1.0. We'll just see what that does. So now if we look at the image, as soon as it exceeds 1, and modulus, well, I guess when it would be positive down here, because it would, like down in the lower left of the image, it'll be positive because a negative times a negative is a positive. So anyway, we're starting to see something, but it looks like something we could get a better look at if we scaled out. So we'll go back over to this, and we can do things like, not center scale, but let's see if I can try. So the input is a point, so we can scale the point down. So we'll make it 1/10 of what it was before. And yeah, let's see what that looks like. Okay, now we can kind of see some of the weirdness going on, and we also notice a bunch of interesting patterns out there, and yeah, it kind of makes you think, oh, okay, what's going on here mathematically? Like, I can kind of understand that how the 0 to 1 works by maybe thinking about, like, right here would be 1 times 1, and then this would be like, I guess 2 times 2, and but well, or wait, whatever the square root of 2 would be, it would kind of hit that line, square root of 3, and so on. But some of these patterns are actually more of a an artifact of the fact that the calculations are really precise, and at the same time the pixels are in a perfect grid, and so kind of the way the calculations line up with the screen, you end up with like artifacts, or I think it's called a moire pattern, and it's kind of interesting and weird at the same time. But you know, if we're just trying to create some random images, maybe we're looking for something like that. So let's try. Let's maybe try messing around with this a little bit more. Maybe we'll take the absolute value of what comes out of x times y. That way we end up with, I guess, more of a fully vertically and horizontally symmetrical version of it. Definitely looks a little cooler, I guess. And then we go back here and maybe change the scale. Maybe we don't want to zoom out quite so much. So let's see if I can flip back over. Okay. Yeah. So you can start to see some of these artifacts kind of like forming out here, but most of it is kind of clear. And I don't know what the video compression is doing to this, so that should be interesting. It probably makes it look extra crappy, but just kind of playing around with this and trying to figure out how to make cool images with like weird little formulas. It kind of tickles the brain a little and makes you wonder what you can come up with. So maybe instead of absolute value, I will do the sine of that value. And then if I'm doing the sine of it, I don't think I would, oops, I need that. If I'm doing the sine of it, I don't think I need like a modulus or anything, because it'll naturally repeat. So let's run that. And then flip over to the image. There, so now we got more of the wave of it. Now sine should go from 1 to -1, so we got kind of extra black space in here. So what we can do in the code is take the output times half, so then it would go from -half to +half, and just kind of bump that up so that it's kind of normalized to go between 0 and 1, because that's how our images work. And our image looks a little bit better. I don't know about better, it's just weird and messes with your eyes if you look at it too closely, because it's just a blurry image. But then let's see, we could do like the distance formula, which is, we should do this separately, so otherwise we're going to end up with like a big run-on line here. Well, I could do it in one line for now, I guess. So get this, so you take the square root of, well, from the center, so we'll take x minus, oh, we don't have the width in a variable. Whatever, I'll just hard code it for now. So we're going to square that. That. Oh, this is horrible. I think you can just, let's just do a separate function real quick. So we'll return a double, we'll call it distance and we will say give me the square root. Actually, you know, I haven't used this library a whole lot. Yeah, I could start throwing the distance formula in here, but I think I have some of this stuff like built up. Wow. So yeah. So common distance. Hey, what's that? That's easier to say than all that other stuff. And I will try to remember what I have in the library and start using it. So, okay, so anyway, the distance from the center, I guess I'm not taking a sign of it, so we don't have waves, but starts at 0, goes up to 1 as we get out to here, and it goes beyond it, but that's just clipped at maximum white. So let's go back to the code. Let's do, now I think you can take the output and adjust it by saying that the output should be the sine, not that sine, a sine wave from the output. And if I run that, okay, so I ran that, and it looks pretty similar, and notice the corners are getting a little bit darker. So what we'll do is we'll just adjust it the other way. We'll expand, we'll increase the frequency basically of that sine wave. So we'll run that, and now we get this crazy thing, which, yeah, this will start to mess with your eyes. It'll, oh, my cat's getting hungry. He's pawing at the cupboard. So let's do that whole thing where we normalize the values to be between 0 and 1. Another way, I guess, to do it would be, no, well, never mind. Just that'll bring the sine wave, close that off. That'll bring the sine wave between 0 and 1. And then we have something probably that messes with your eyes even more. And yeah, we could make the waves a lot smaller. And so every time I run this, I'm basically, it's just like executing a program that writes out the file, and we'll see what the compression does to that. Ugh, that I don't want to stare at that too long. So anyway, I've kind of established what I'm doing here is I'm starting to, in a, hopefully a fairly simple way, just kind of say that I want to take the distance and adjust the output of it by, you know, making a sine wave, and this is generating some graphics. So maybe I'll stop there and jump in when I have an idea of something better to make for the next one, and hopefully I'll go at a better pace. This is probably really boring, but anyway, if you watch that, wow, thanks.